This is our chemistry lab tutorial on conducting a distillation. So you may ask, what is a distillation? It's a separation technique based on boiling point. So the idea that every liquid has a different boiling point is what we can use to help us with the separation. You can isolate different liquids from a mixture of liquids. So if you know you've got a mixture that has more than one component in it in terms of the amount of liquids it has, you can try to separate those back out based off of their different boiling points. It's essential in the petroleum industry. So how do we get the gasoline that you know when you go to get gas in your car versus other types of alcohol and petroleum products that we would interact with? You can also think of it in the word distilled water. So if you go to the grocery store and buy a gallon of water and it says distilled on it, that's what we're talking about here. So what does the setup look like for a distillation? Well, this is a setup that we will be using in the chemistry classroom this year. So you can see that there's a lot of components involved to it, and it looks kind of complicated when you first look at it, but what we're going to do here is we're going to really try to break it down and figure out the different pieces of equipment that are needed and how to set them up in a reasonable and logical order. So let's break it down. What materials are needed? You need round bottom flasks, which is something that's new. We'll use two different sizes, one's bigger than the other. Glassware clamps, thermometer and an adapter for a thermometer, condenser, support for the glassware including ring stands and clamps, and a heat source as well as tubing, and you'll see why we need those, specifically two pieces of tubing. So the equipment explanation we're going to start with is for a round bottom flask. So these are our two round bottom flasks that you'll be using. So we have a 100 ml and a 250 ml Pyrex round bottom flask. So they are called round bottom flasks because they are indeed round on the bottom. So this round shape is important because it's more resistant to fracturing. That's because the round shape helps just evenly distribute stress as it gets heated and so forth. Also allows for more uniform heating. There's just a wider surface that the heat can be applied more evenly. So in terms of the next piece of equipment, these glassware clamps, they look like this, the ones that we'll be using. They have this blue color, and you'll notice that they have two kind of ring parts to them that you can use to help you attach them, as well as the little support clamps on the side. So we obviously need to support the glassware during heating. First of all, it's very expensive. Second of all, if it breaks in the middle of your distillation, you're going to have to start over. These clamps allow for the joint to be supported so the glass does not slip at this point. The thermometer, pretty self-explanatory, look like this. We measure in Celsius in chemistry. And that's a little adapter that we use to help seal off the joint, because if you think about it, you're going to put a thermometer in, there has to be an opening for that. We want to make sure that nothing can escape in this opening. So distillations require careful attention to the heating process since we are trying to track those boiling points, so quite literally the temperature at which that liquid boils. And then the thermometer again uses that adapter to seal off the apparatus to make sure that none of the gas vapors escape through the hole that the thermometer is being placed in. That hole perfectly fits to that thermometer so that there's no room for any of the gases to escape, which would affect your data and your process in general. The placement is important. We'll get to that when we do some videos of how to set this up, but just keep in mind that it is going to matter where you put the thermometer and how far into the apparatus itself it goes. The next piece of equipment that's new is called a condenser. So the condenser looks like this, and it technically has some joints to it already, but the main definition of the condenser is that middle part with the two valves that come off the top. We'll talk about how we're going to set that up and use it, but it's the connection glassware that basically allows for the liquid to go from one round bottom flask to the other. And the water will also run through this piece of glassware, and you'll see what that looks like in a little bit, but that's why there's those two valves at the top. This piece is essential in having the gas condense back to a liquid because this is what will allow the gas to be exposed to a colder temperature, which will make it then condense to a liquid. In terms of supporting the glassware even more, we need to have ring stands. So like that picture there, we will have two of them. And clamps, again, we will use two of those as well. That's just to stabilize the glassware because the glassware is really important. It's why this whole thing can work. And it needs the support again so it doesn't break, which means you'd have to start over, as well as the fact that it is really expensive. In terms of the heat source that we will use a heat source that looks like this, okay? It's not the most modern piece of heat source, but it works pretty well. So you need heat to vaporize the liquid. You need to heat up the liquid to create it, to cause it to evaporate into a gas, which is at the core of this process. We obviously need a rounded heat source. since the round bottom flask is being used. So you'll see in this picture of the heat source, there's a rounded kind of sloped area, and that's what will allow it to perfectly hold the round bottom flask itself. In terms of the materials, what we're going to do next is we are going to look at like a little video clip of these being supported themselves, right, in the lab setting, so that way we can try to understand how to set this up. So when preparing to do a distillation, the first thing you want to do is gather all of your materials like we have here. Okay, we've got our heater on the left. I do have it plugged in. That whiteboard's there just to help us see the glassware once we get this set up. We've got our condenser, our thermometer with the adapter. We've got 2 clamps, 2 support stands with the ring stands there. We've got 2 of the little blue clamps for the glassware, and we've got the 2 round bottom flasks as well as 2 pieces of tubing that we're going to use for our water. So the first thing we've done is we've got the clamp set up on the ring stand with it overhanging the heater, so that way the round bottom flask can sit in there. So we've got a round bottom flask that we will connect to the condenser. They kind of nest right in there, and we're going to go ahead and connect it to that support clamp there. But the other thing that you want to be careful of is we will use these blue clamps to help make sure our glassware stays together and doesn't fall apart. One thing to notice on the clamp, one side is bigger than the other, as you can see here. So if you are having trouble getting it connected one way, you want to be able to flip this around and get it connected that way then, so it works well. So this is what the first part of the completed setup should look like. We have our clamp supporting our glassware. We've got the blue clamp supporting the 2 glassware junctions there to make sure that they stay supported. We've got the big round bottom flask that you would put your sample in here, whatever that may be, first before you assemble this. But once your sample's in there, you'd have it assembled like this, where this is nested in the heater. So therefore you can go ahead and heat that round bottom up pretty hot and pretty easily, because it's connected and it's sitting directly on this coil, which is what would heat up using these heat settings here. So once you have the rest of it set up, it should look like this. We've got another blue clamp supporting the second round bottom flask at the junction between the condenser and the round bottom flask itself. If you were doing different fractions that you were trying to distill, you would replace this with something that's easier to swap in and out during your heating. So like an Erlenmeyer flask or a graduated cylinder, or even a beaker, just something that would be quicker to do. This, because of this junction here, would take you some time to take this off, sub this out, and put something else on, and you want to be able to collect quicker than that. So the reason that it looks like it's slanting a little bit is just simply because the way this clamp is holding it, but it's all right because this is still sitting right onto the coil, so that's okay there. We added the thermometer. The general rule of thumb is that the thermometer reader should go a little bit past this conjunction to the condenser, okay? You can even raise this a little bit too. Really, as long as it's close to this juncture point right here, you're doing okay. You don't want to have it too far down in here because you don't want to collect the wrong temperature. You want to have it closer to the top to see what it's actually collecting in the vapors here, okay? But then as we look at this, the next thing we need to do is connect our tubing, which will run from these 2 points here into the sink. And you want to make sure you can turn it on and get it flowing, but make sure that your junctions are connected well before you do so. So I went ahead and connected the tubing now. So you'll see that I like to use 2 different color tubing, so that way I remember which one to connect, but you can use the same obviously as well. Whenever you do the water for the condenser, it might be counterintuitive, but it has to go in here and then out the top. Okay, that's to make sure that there's still cold water running through the entire condenser, okay? Because the pressure will make it flow up through here pretty easily. So when we try to turn this water on, we will be able to zoom in here and kind of see what the water looks like. So I'm gonna move in a little closer. We go ahead and turn on the water from the sink. I have the other one draining over here into this sink, okay, from the upper end. But when we go ahead and turn on the water here, okay, so if you looked really closely here, you would see water moving through it. I don't have any air bubbles, which is a good thing, but if I feel this too, I can feel the water moving in and I can hear it draining out into the sink here, so it's definitely running. But so we're looking at the water flowing in through the red line, out through the top, okay? And at this point, we have the entire setup ready to go for the distillation. So once I had my sample in here at the very beginning, I don't have one right now for this purpose, but when I had one in there, I'd go ahead and crank this up to whatever's appropriate. I will be monitoring this temperature to try to see at what point I expect whatever my sample is to vaporize and then condense down here. And as the distillation were working and you would see it start heating, what you would actually see is the liquid's going to vaporize to a gas. Because this is really cold, it's going to flow through here and recondense back into a liquid. and then you would see it start dripping down into your collection flask. By monitoring the temperature, then you can collect whatever you're interested in collecting itself. Okay, so again, I'd zoom in close. I would have a sample down here. This connector joints, making sure these two glass junctions don't have any issues. Got a thermometer to measure the temperature of the gas as it vaporizes here. It would then flow down through this colder tube because of the water flowing. And again, you can hear the water draining into the sink here. So I would have it flowing down through here, and then because this is cold, it would cause the gas to condense back to a liquid, and I would see it start dripping out through here. And then I would stop at whatever temperature I was interested in trying to stop at to make sure I'd prevent something else from getting into my flask that I'm collecting, okay, my round bottom here. If I were looking at an organic compound, generally they all have boiling points less than that of water, so I would want to turn it off before I get to the 100 degrees Celsius boiling point so that I try not to get any water in here if I think that I have water in my initial sample. Right, and that's pretty much it. I have had students get creative with holding these tubings back with clamps or something like that. You just want to make sure they're not close to this heater here because the rubber obviously could burn and create quite a smell if it does connect there. Let's talk about disassembly real quick. So when you are done with your sample, keep in mind that you will have some really hot pieces of glass. This round bottom flask will be really hot as it had just been heating. It's possible this condenser is pretty hot. This round bottom doesn't normally get very hot, but you would want to be careful as you touch that. You want to make sure the fact that there could still be water in these tubings, so as you disconnect them, be aware of that. And the general rule of thumb is we make sure this is off. We might need to move it to a better location depending on what is coming in next after your class, but we will leave these to cool. And I will not have you try to just disconnect it on your own knowing that they could be pretty hot. This does have water in the condenser here, and you can see that, so we want to make sure that does get drained out. We don't want to leave water in it, and we don't want to leave any liquids in any of these glassware. We want to make sure that they're dried out pretty well using acetone or water or whatever we need to make sure that they are not creating coatings that leave on the flask that would prevent our next sample from being accurate.